This is a calculus problem that worries about asymptotes. These are often called limits at infinity because asymptotes are as the input or the output approaches infinity. So notice this function isn't quite a rational function because it has a square root, but we can still worry about vertical asymptotes and horizontal or slant asymptotes. Vertical asymptotes are where the denominator is 0 and the numerator isn't 0. So you see the denominator is 0 at x equals -2, at x equals 3, right? And you could probably verify that those places aren't places the numerator is 0. What is the limit that corresponds to that? Well, we can ask what happens as x approaches -2 of the square root of 5, x to the 6th plus 2 minus x squared over x plus 2 x minus 3 squared. Well, let's sort of think about that. The numerator, -2 to the 6th, that's going to be positive, I suppose. 2 times 2 times 2 times 2 times 2 times 2, maybe that's 64. You got a pretty big number here, but it's positive. Take the square root, minus 4. So this is a positive number, but most importantly, it's non-zero, right? So you got something non-zero over, that's going to something non-zero. This is going to 0, right? Notice that from the left, if this is like -2.1, that's -0, and from the right, it's +0. So you got a 0. Part of the time it's positive, part of the time it's negative. It's getting really close to 0. And this -2 minus 3, that's -5 squared, that's 25. So the point is, you've got 25 times 0 is still very 0. You've got something that's shooting off to positive infinity on one side and negative infinity on the other side. So what we write there is the limit does not exist. That's a little bit different than this case, and I think that's worth mentioning. The limit as x goes to 3 of the square root of 5x to the 6 plus 2 minus x squared, you can sort of confirm that the numerator is going to be non-zero, same way, right? X plus 2, that's going to be, what, 5 times x minus 3 squared. Notice, if x is coming, this limit could come from the left or the right. If it comes from the left, this is going to be like a -0.1, -0.01, but we square it, and so it's positive. And then if it comes from the right, it's positive, and we square it, and it's still positive. So this is going to 0, but it's positive, right? So this is non-zero. Maybe I should say it's non-zero and positive, right? Greater than 0. So we've got something positive divided by 5 times a positive very small number. So this limit shoots off to infinity, right? This one shot off to infinity on one side and negative infinity on the other side, but those are the two limits that I can evaluate that correspond to the vertical asymptotes. Two different kinds of vertical asymptotes, by the way. Now let's think about horizontal asymptotes. Horizontal asymptotes, I'm thinking about what happens to the limit as x goes to infinity of, let's see, 5x to the 6 plus 2 minus x squared. We'll worry about x going to negative infinity in a moment. Just think with me here for a moment. Okay, so what I'm going to do is I'm going to take the highest power in the denominator. So if you multiplied all this out, can you see you'd have an x times an x squared? That's an x to the 3rd. So I'm going to divide everything in sight by 1 over x to the 3rd, or you could write x to the -3 if you don't like the fraction notation. Okay, but what does that do? Let's see. Now I'm going to distribute that term. But I'm going to distribute it, in particular, I'm going to distribute one of those x's to this term. So that's 1 plus 2 over x. That's 1 over x there. I'm going to distribute x squared to this term. So that's 1 minus 3 over x squared. And then this has to be distributed to both summands. The first one that I'm going to do is the right one, just because it's easy. The left one's a little less easy. I need to put that inside a square root. So you can think about 1 over x to the third as 1 over x to the sixth square rooted, right? So think about that. Hopefully that makes sense to you. And so then instead of multiplying this term by 1 over x to the third, I think about it as something with a square root, so I can put these two terms together. This term distributed to that, right, makes for 5. Distributed to that is plus 2 over x to the sixth. Now I can think about all the individual terms and sort of see what happens. This term goes to 0, this term goes to 0, this term goes to 0, this term goes to 0. And what do you get out? You get out the square root of 5 plus minus 0, I guess, minus 0 over 1 times 1 squared, right? So that says the limit, as x gets really, really big, is the square root of 5. Now, sometimes you can just put a plus and a minus there. We need to sort of pay close attention to what would happen if these numbers were negative. It's totally fair game to multiply by 1 over x cubed in each term, but let's sort of think about these steps. What would happen here? Let's see. So is this still true if you have negative x? No, it's actually this, isn't it? So think about that. 1 over negative 10 cubed is negative 1/1000th. Well, that might just throw a monkey wrench in our plans. So let's have a look. X to the negative infinity, okay. So there's no problem with this. And then I'll write this distributed to each term so we can look at it really precisely, or slightly more precisely. Okay, so I'm going to multiply each term by its own version of this, right? So in the denominator, 1 over x cubed, I've got this times 1 over x. That's just fine. If that were negative 10, no worries there. Then I've got x minus 3 squared. That's always going to be non-negative. 1 over x squared. No worries there. Square root of 5x to the sixth plus 2. Then I'm multiplying that times actually negative 1 over x to the sixth for the reasons we outlined above. Then let's see, this last term is x to the third, x squared times 1 over x to the third. Okay, so we'll put all those limits together. And the catch is the denominator looks the same. The numerator looks the same as this up here, by the way. This term even looks the same, but this term, that square root, that's squaring and then square root, actually is now negative, right? That negative is going to go out in front. Square root of 5 plus 2 over x to the sixth. All those terms go to 0. And what we get is the same thing as up here. We get negative, except for that negative the square root of 5. And you can actually look at this function. You can look at this function, have a look at the graph, and there are actually 2 horizontal asymptotes. Very sneaky because of that square root. But this is the limit notation that corresponds to limits in infinity and asymptotes.